Hi, this is Margo. This is Sunday afternoon, July the 12th, 2020. I hope everyone is doing as well as possible. I'm hanging in there. And today's report, I'm going to focus on methane and Arctic sea ice. And we have 2 days worth of data for CAMS and for NOAA to go over, because I didn't do a show yesterday. And we have on CAMS we've got Saturday and Sunday data, and on NOAA we've got Friday and Saturday data, and we'll do the weekly NOAA update. So let's get started. I wanted to show you something interesting before we get started. Now look at this is the Arctic view and methane. This is for yesterday, and see how it's all like in the greens and then the lighter greens going across. Greenland is in the kind of aqua color, but notice that the background color is pretty much all at least green from this North Atlantic going up. I was looking back through my videos and pictures from last year, and this was the title page from my video that I did on July the 13th, and it was for methane data for July 11th and 12th, so it's the same time frame here. And look at the difference. Now this is the North Pole view, but look, it's not solid green throughout there, is it? There's that aqua color going all the way through, and so there's a huge difference. And this year we've got a bunch of green going down further out, further south. And so it's some of these background areas that have really changed in the colors that we're not aware of, because if we're looking at it on a daily or even a weekly basis, these changes are subtle and we don't realize, difference unless we go back a year ago or 2 years ago. Now this is my third year, going into my third year of doing this. I started in April of 2018. So I've done 2 full years of reporting on methane and sea ice. But last year I started doing daily updates once I got my Subscribestar page set up. And we started seeing methane really going up. And if you're not aware, here's my website, Margo's Healing Corner, and Subscribestar archives, and I have all of my posts archived here except for just like the last month or so. And so you can go back and see what was happening during any of these months. Starting, I did a few posts at the end of March, but starting in April is when I started full reporting over on Subscribestar. But if we look back to July, here's July, and here's methane from July 1st that I did on July 1st. It's a whole report. It's a half an hour long, and there's other stuff too, but I title it Methane Data from CAMS so that we know what day I'm reporting on. Here on July 2nd, you can see the background colors there, and earthquakes and different things. And so I encourage you to go back and see And see the sulfur dioxide here? This was from that Russian volcano in the Kuril Islands, the Rykoki volcano. That little tiny thing that went off, and that's reminiscent of what we're seeing in the Western Pacific with the Nishinoshima volcano that's been erupting since June 19th. And see, I have earthquakes, I have everything. So there you go. And you can go and see what the methane was like for that day. And a lot of times I report on sulfur dioxide and ozone too on these. So there's that. I just wanted to bring that to everyone's attention. And we're going to be looking at Climate Reanalyzer in a moment. So I want to start out with methane. So we're going to start with the NOAA data for the 477/469 millibar reading for Friday, July the 10th. This is for the METOP-1 satellite in the morning. The mean or average was 1,895 parts per billion, and the high reading was 2326. So in this range, this pink color down here, that's the high range between 2,000 and whatever this high number is. And like in this case is 2326. And notice we had pink over the southern hemisphere. It's moved further south. And when we look at the CAMS data at the 500 HPA level, you'll see that the greens for that level are further south as well. And it's a subtle change that we see on a daily and weekly basis. Now in the afternoon, the mean was 1896 and the high reading was 2370. On the METOP-2 satellite in the morning, the mean was 1879 and the high reading was 2326. And in the afternoon, the mean was 1877 and the high reading was 2594. So I'm going to go on to the next methane data, the next NOAA data. I'm going to close these out as I'm done. Might want that one again. Now for Saturday the 11th, for the METOP-1 satellite in the morning, the mean was 1894. The high reading was 2304. In the afternoon, the mean was 1895. The high reading was 2283. Look at all this missing data. Isn't that crazy? All those white spots. Anyway, here on the METOP-1 satellite in the morning, METOP-2 satellite in the morning, the mean was 1880, so that's an increase. The high reading was 2246. And in the afternoon, the mean was 1878 and the high reading was 2246 as well. So let's hop on over. Now I've changed up my chart a little bit. I moved my daily data over to a separate page. I just this year in February I started tracking it on a daily basis because I wanted to see what it was doing more than just week to week. So here we were on July the 4th. Okay, so for these last 2 days, for the 10th, the average comes up to be 1886.75, and then for the 11th, the average was 1886.75. So no change in the average from Friday to Saturday, but the Friday reading had gone up 1.25 parts per billion from the day before. So overall, so here's from last Saturday, the 4th, which was on my last report, my public report at YouTube. Our average was 1882.25. So that was an increase for over the week before of 1 part per billion. Now here's what happened during the week. On Sunday, it went up 1.25 parts per billion in one day. On Monday, it went down 0.75. On Tuesday, it went up 1.5. On Wednesday, it went up 1.25. On Thursday, there was no change. On Friday, it went up 1.25. And on Saturday, there was no change. So we come up with an increase over the week of 4.5 parts per billion. And since March the 8th, when it started really zipping up this year, it's gone up 23.5 parts per billion. That's an insane increase. Insane. So here's the chart. I put that on a separate page for weekly chart. So here's the Saturday data, 1886.75. Here's last Saturday, and here's the increase. And here's our chart over here, where it's almost straight up, of 4.5. Now, of interest here, yesterday, which was the same reading, or on Friday, which was the same reading as on Saturday, 1886.75, we crossed the highest reading that I recorded last year. That happened in October, for the week of October the 12th. The high reading, the average was 1885.75, and then it started going down. But it had been on the increase since, well, I started recording it March the 1st. But it had been going up somewhat before that, and Dave Alcock and I were charting this methane together for a while, and then we both decided to kind of do our own reporting. And he was tracking a lot of different levels, and for me, I wanted to make it easy, and I thought, well, I'd like to just track this 477 millibar, since that's what one of the ranges we'd started with, and it's a range that a lot of climate scientists like to use. So it went up, and it peaked out October the 12th at 1885.75. So we've already passed the peak, and we're at the beginning of the methane rising season. So we passed last year's peak already by one. We're already 1 part per billion higher than we went last year. So here's the change from since February 29th. It's gone up 10.25 parts per billion, and since March the 1st of 2019, it's gone up 29.5 parts per billion. So there's that. So it's not looking good. Not looking good at all. So let's move on to cams and get these movies going now. Okay, we're going to start with Saturday the 11th, Arctic view and surface level. There's our color ledger. And so these greens, like this solid green, is 1920. No, wait, that's 1920 parts per billion. So that color here, that's already 1920 at the surface. So this is different than 500 HPA. We'll look at that in a minute. And as you go into the lighter greens and the yellows, it goes higher. Like this chartreuse color right in here, that's 2000. And it goes up. This bright red is 2100. And then this dark reddish brown is a range of 2160 to 10,000 parts per billion. They cut their chart off at that. It used to go up to 65,000 or something, but they downgraded everything. They changed it. Now they can't, if it's over that, it just goes white. That's what I found. So let's run this. So this is where it left off on Friday. With now we had seen during the week there had been a big release here from Severny Zemlya, and the arm had moved out across the North Pole and all the way across the Arctic and swirled around and came around. So that's finished. Now this is a new release coming up from Friday. And so we're going to see what happens here. We're still looking at this problem area in the North Atlantic. Iceland has some popping up on it. We have the Scandinavian countries are covered. Russia, this northwest area of Russia is covered. You can see these background colors are higher, and Russia's popping back up, filling up with methane now. And it's popping back up in the United States and North America or Canada from about the middle all the way over east, and it's popping up in Alaska pretty good. So let's run this. So this is the North Pole, the Arctic view. So the data is for Saturday and the forecast is for Sunday through Wednesday. So it looks like the Saturday release, Friday and Saturday release dissipated, and then a new release is going to be coming up. And I've noticed a pattern that it usually kind of clears out around the first part of the week, and then by Tuesday or Wednesday we've got a huge new release here at Severny Zemlya. Look at this area in Russia. Now there's a bunch of wildfires burning. They've kind of moved over to the west. We've got high releases in this area. But see these waves moving out? That's methane coming up. You can see the different colors of green, and that's coming up through the sea ice. Now let's hop over to Sunday, the same Arctic view. So here's starting at the end of Saturday. There's a little bit of blue here, so that's a little bit lower, but it's just a little tiny bit. Look at this, it's all covered up here in Norway, Sweden, and Finland. My headset squeaks. I'm sorry about that, but when I move my jaw a certain way, my headset squeaks. So it's the way it is. We've got some high releases off this eastern seaboard of the US and Canada here. Okay, now it's in the forecast period. So the data is for Sunday and the forecast runs Monday through Thursday. So here's Sunday, so that kind of cleared out. So by Tuesday it's starting to come up again. Wednesday is a big release, and Thursday. So that's the pattern. I don't know if there's drilling going on or if it's just like a constant rift now coming up. So there's that. Go back to there. Now let's go back to Saturday, and we'll look at the North Pole view. We can see pretty much the whole northern hemisphere here. So this is Saturday. Here's the Persian Gulf. See, it's filling up and spilling over on land. Here's India. It's filling up more. Here's China, and down into South Asia, and this is Korea here in northern China, and then the Russian border starts right about here. Here, look at the US here, this northeast coastline. Watch that big black blob. And we're starting to see waves move out now. And as things heat up, you'll see more and more waves of methane moving out. But what's weird is we have masses of cold air right next to masses of warm air, and so where it's cooler air, the methane is lower. Where it's warmer air, methane is higher usually. Well, let's go to Sunday now. So not a lot of difference from Saturday to Sunday. Now let's go back to Saturday. Look at the global view. Look down here, we've got it coming up in the Antarctic. This is the Western Peninsula. It's coming up to the south of there. and then on this tippy point side, this eastern side, and on the coast of the Weddell Sea. And it's dark down there. It's winter time and no sun for months. And just the opposite of the sun shining continuously in the Arctic now for months. Now let's look at Sunday. Streaming out, see this? Streaming out from South America. Watch this. Look at that high area there. And up here too, in the northern part. Brazil, Colombia, there. We'll go back to Saturday. We'll look at 500 HPA. And I'll refresh to get the correct color ledger. So this is Saturday, and the numbers overlap here. The high reading is 2360. I think it's 1950 to 2360 is the range there. Now notice the green going all the way down here. This range is see the greeny aqua, that's like 18. These are in the tens. 1810 to 1820 down here. So what we're seeing, it's very high over China and India, and then over parts of the Arctic. Now we're not seeing it solid red like we have seen some in the past, but we are seeing higher readings spread out, not just over the Arctic. And the high readings, the methane likes to gather in colder areas, but it's warmed up so much up there, it's methane's kind of moved around. So we'll see if Sunday looks different. Yeah, it does look a little different, doesn't it? Here's China, India, and we've got big bunch of green area here in the United States. But look, right next to that is the red and some dark red. Now we'll go back to Saturday. We'll go to total column and we'll refresh. Get the color ledger. There it is. 2320. And it goes from 1920 to 2320 in this dark brown. And this darker red is 1900 to 1920. There it is. Look, it's red here over the Persian Gulf. And it's reddish orange over a lot of India Saudi Arabia, Africa, and parts of South America. And if you look back through some of my older videos, like last year, it wasn't, we were seeing lower readings down here in the Antarctic, because see, around this coastline we're even seeing like this blue and this blue-green and this 1740 blue-green. And last year we were seeing down into this purpley, light purple on some of it, and this dark purple. So 1660, we were seeing those, and we're not seeing that now. We got blue, that blue, which is 1680. So it's rising all over the world. So we'll see changes in the colors, and the greens have gone further south, and the yellows have moved further south as well. So there's that. Now I want to finish up my slideshow. Wanted to show a couple of other things here. We have an ozone hole forming over the Arctic. This is from today from CAMS, and the bright yellow is 300 Dobson units, and then the greens, chartreuse green and blue, are below that. So it's right over the North Pole. And that's highly unusual, especially in the summertime. Now I'm going to run through sulfur dioxide. We're still seeing this high event level going on in the West Pacific. It's because of that volcano down here. It's a Japanese island, tiny island. That's just a volcano pretty much, and it keeps going off. And it's hanging around. It still keeps going off, and so what's already been released is still hanging around in the atmosphere. Here it is at 500 HPA. When we look at the Pacific view, you'll get a better idea. Now here's the East Tropic view. We can see it's high up here in China and across the mainland. Here's India. Here's Saudi Arabia. It's getting higher there, and so on. Here it is at 500 HPA. Some of this is new from today, and then the rest of it is what's just gathered and hanging around. Here's the Pacific view. You can really see how it's moving out, and some of it split off and come up over North America, and some of it split off and going up over Alaska, but it's all going up into the Arctic eventually. Here's 500 HPA. Now this is from Popocatépetl, the volcano. So that's constantly going off, so that's just minor compared to this other. Now this area up here, this in Russia, that's from wildfires. Here's the North Pole view. We can see it's getting higher across the North Pole. And sulfur dioxide will eat away at the ozone. So it could be the ozone hole is forming because of this continuous sulfur dioxide up there. Here's the 500 HPA level. Here's the South Pole. And 500 HPA. Here's the African dust cloud. I think this is round 5. It's well formed and almost all the way across the Atlantic now. It's hitting the Caribbean islands. And looks like the north coast of South America. These are the fires. These are from cams today. These are the fires burning, aerosol burning, biomass burning. This is Africa, and this is Russia, where the wildfires are, and some more up here. So these fires are also contributing to problems in the Arctic, because there's smoke, and that's toxic. And so when it's raining or snowing, then it comes down on the sea ice, and it's got ash or it's got acid from the sulfur dioxide, then we got problems. So that's all of those. Now I have another slideshow ready for you. Now we're going to move on over to sea ice. I'm starting with sea ice and snow cover for last Sunday, July the 5th, from Climate Reanalyzer. This is where we were at a week ago. We were seeing melting around the coastlines and thinning. There had been a hole that had opened up here in quadrant 2. I'm naming them 1, 2, 3, and 4. But it had closed back up. So let's run through this and see how it progressed during the week. Here's the 6th, 7th, 8th, 9th, 10th, 11th, and here it is on the 12th today. So we can see the Baffin Bay is cleared out next to Greenland. The Hudson Bay is almost all cleared out. There's a hole opening up here on this eastern side of the northern tip of Greenland, but when we look at NASA Worldview, you'll see that the ice is already broken away from the coastline up here. And we can see it's melted here in the Beaufort Sea all along Alaska, and it's melted all around the edges of Siberia now. And Novae Zemlya is just kind of sitting there. The Barents Sea is clear, the Kara Sea is clear, the Laptev Sea is clear. This is the East Siberia Arctic Shelf all across here. This is where those high stores of methane that Natalia Shakova found. But we saw from Sam Carana that there are high methane stores in the sediments all the way across, all the way, everywhere under pretty much. So we're just waiting for something to blow out. And it will. It's just a matter of time. This is the Navy sea ice thickness from today, July the 12th. I'm going to zoom in. This is their model. So here's where we are. Now the purple, the solid purple is about 1 meter thick, and the lavender is about 1/2 meter thick down to 0. The dark aqua is about 1.5 meters thick, and the light aqua is about 2 to 2.5 meters thick. The green is about 3 meters thick, and then the red starts at 4 to 4.5 meters thick. Now, the thick sea ice, what we used to have that would cool everything off, keep everything cool, and act as the world's air conditioner, was up here, and it was a big ice cap that was 20 feet thick, meters and meters thick. But now we can see it's all melting, and there's just a little sliver of red here on the northern coast of Greenland, and right here on the edge of the Beaufort Sea. And it's melted and broken away and melting around these coastlines of Canada and Greenland now. So it's melting out now. It's going to start melting out from the coastlines. And we can see in our quadrants, in quadrant 1, what's left is mainly in the lavender and the purple, which is 1 meter and under, or 1/2 meter. In quadrant 2, same thing, but very little sea ice right there. Quadrant 3, it's about average of 2 meters thick, 2 or so. And quadrant 4, 2 parts in 2 and parts in 1 and under. Here's the 30-day animation. This is from the Navy again, so it goes back 3 weeks. It's data from 3 weeks ago, which was, I think it's the 20th that it's starting on. Yeah. And then it goes forward a week out from today. So it forecasts out to the 19th. So I'm going to zoom in while this is going. So we can get a good view of this. Look how fast it's melting. It's just shocking. I was practically sitting here in tears watching this yesterday. And you can see this thick, what's left of the thick sea ice, you can see it melting and moving down through the tributaries, moving out. And then big hole right there opening up, and a big hole over here. And then it's broken away here on northern Greenland. And now once that's broken away, it's all going to start melting out. And this is not looking good. So I'm going to pause it. Okay, here's on for the 30th. I mean, not the 30th. This is the 30th day, the last day in the animation. And the forecast for, they're forecasting for July 19th on this. This is where they're anticipating the sea ice will be a week from now. Now we've got white spots all the way through here. It's just very thin all the way across from the Chukchi Sea, across the Beaufort Sea. It's opening out from the coastline out here in the Beaufort Sea, and now it's going to start opening up here all around these coastlines. Here's the North Pole. So what's left of the thickest sea ice, it's all right here. Little tiny half circle. So that's where we're at. So we'll do one more thing while we're here. We'll go back. Let's see. Trying to get today. That's the 11th. Okay, so here's today. We'll click through slowly and you can watch the change. It's dramatic watching the change day by day. It's the 13th, 14th, 15th, 16th, 17th, 18th, and the 19th. We've got a hole opening up here, just north of Greenland. Svalbard is clear, pretty much clear of ice here. This is Franz Josef Land Islands. Here's Severna Zemlya. Right down here is where the methane has been spewing up since January. So there's that. Now let's move on. I'm just going to briefly show Climate Reanalyzer. Here's the temperatures for today. We can see in the southern part of the United States, Texas, Arizona, California, they're in the white range, which is getting very hot, up to 50 well, between 40 and 50 Celsius. And all of northern Africa is in the white range, and look, parts of India and these Middle Eastern countries. Here's the 2-meter temperature anomaly. So we have right next to these really hot areas, we've got really cool areas, and this is part of the big change in the climate, and this is one of the effects of what's happening. And so when you have the cool air masses meeting up with the warm air masses, you have violent weather, and the jet stream is broken down and all this, and so it's going to be hard to grow food, and there will be flooding, will be dry. Where it's dry, it'll be drier. Where it's wet, it'll be wetter, just depending on where you're at. So here in the Arctic, it's brown, or about, looks like 10 degrees Celsius warmer than normal. Back up here around the Siberian coastline. Then it's tan, moving out across the Kara Sea and across, and Greenland is brown now. We've got brown through the western part of the United States, brown up here in Canada. Here's the flat view. See, it's moved down through Russia, here into Kazakhstan. Now the Antarctic is coming back to life. We've got some reds down here, warmer than normal. So overall, worldwide, we're up 0.4 C, higher than normal. The northern hemisphere is up 0.6 C. The southern hemisphere is up 0.2 C. The Arctic is up 1.2 C. The Antarctic is up 2.4 C. And the tropics are up 0.6 C, higher than normal. Here's precipitation and clouds. The green is rain. We can see it's raining up here on the northern coastline of Siberia and over here into the Laptev Sea. And here on this eastern coast of Greenland, Iceland's getting rain. Here it is around the globe. Let's look at sea level pressure. We still have this high over the Arctic, and the low is over here over Russia and Canada. So that's all out of whack. And we've got a high here in the Pacific. Here's the jet stream. It's pretty weak. It's hard to tell what it's doing here because it's not very strong in the northern hemisphere, but you can see that it's very broken up, very loopy and pretty weak. But look how strong it is in the southern hemisphere, but it's very broken up as well. Sea ice and snow cover, we just showed that. Sea surface temperature anomaly. Now this is updated only to Friday. This is the latest data. But look at this all around Novaya Zemlya. It's red and brown, and also going up into this pinkish range, which is up to 6 degrees higher than normal. And all around the sea ice, it's either brown or red, all around the edge of the sea ice. So here it is in Baffin Bay. This is all melted there now. Here's the Hudson Bay. That's where it's all melted. Look at this Pacific Ocean. Now let's get the flat view. So here's the Pacific, big blob of hot area. And so on. It's awful. So overall, worldwide, the sea surface temperature is up 0.4 C, higher than normal. The northern hemisphere is up 0.8 C. The southern hemisphere is up 0.2 C. The North Atlantic is up 0.6 C. The North Pacific is up 0.8 C. And the Equatorial Pacific is up 0.3 C. So the North Pacific wins out, along with the Northern Hemisphere. They don't have the Arctic listed as an ocean to measure, but it's included in that Northern Hemisphere reading. So there's that. Now I wanted to show, this is NASA Worldview. I'm going back 10 days. This is sea ice concentration, and the reds, it goes down backwards in the rainbow for how much it's melting. But you can see where it was melting back then. Let me take out these clouds. We'll go to the blue marble layer, turn that on. So let's go through this and you'll see what's happened since July the 2nd. And we can see the melting, high melt that day. That was on July the 4th. Here's the 5th, the 6th, 7th, 8th, 9th, 10th, 11th, and today. So we've got another high melt day. Look, it's going up. That's what I said it was going to do. It was going to be melting from the coastline out here, which is what it's doing now. There's a hole forming here, just north of Canada. That's in the Beaufort Sea. Here's the North Pole. So let's turn the clouds back on. And we'll turn this concentration off. Before we look at the sea ice, here's the sea ice index from the National Snow and Ice Data Center. Here it is, the concentration from yesterday. So that correlates with what we just saw. Here's their graph. This is Arctic sea ice extent. This is the area of ocean with at least 15% sea ice. And the blue line is this year. This dotted line is 2012, and that was the year that it was the extent was the least in our recorded history. And we're below that. We're at all-time record low for this time of year. So our extent is below 2012, and remember, in 2012 it was a lot thicker than it is now. Here's the Greenland Ice Sheet today, also from the same website. Here's what's melting today, the salmon. This is all melting, this in the salmon color around the edges of this ice sheet. And this water is cold and it's flowing out into the ocean, so it's cooling down the ocean and it's messing up the AMOC. Here's the melt, cumulative melt since January 1st of this year through the 11th. And down here is their color-coded chart of the number of days of melt that it's melted this year. See, like down here, that's like in this, almost in the yellow. So that's about 45 days of melt down here on this western side. We can see it's melting on the interior even, so that's not good. And this is the Greenland melt extent. This is the melt percentage. The red line is 2020. We can see that it spiked. It went up in May, higher than normal. Here, the blue line is median from 1981 to 2010. but we can see that in June it spiked up, and it's been above that median ever since then. And then look, it spiked up way again. Looks like at the end of June or 1st of July. And this was, that percentage looks like about 33% melt extent. So the Greenland Ice Sheet is not looking good. So there's that. Now let's actually look at the satellite view of the sea ice. I'm refreshing to see. Okay, we've got most of the data in. So here we are. Here's the Arctic. Here's Greenland. This is a cloud over here. This is not sea ice. This is totally clear of ice now. It's melting up through here somewhat. This is ice, but it's starting to melt, see, through these little channels. I wanted to show here at this northern tip of Greenland, see how it started breaking away, and it's broken away here. Here's Canadian islands. This is where the old sea ice used to pile up along the coastline. But see, it's broken away, and now it's going to start melting out, as well as from above and below. Here's the Beaufort Sea. Now last year this had all melted by now, but we have a different pattern this year. We have a little ridge of thicker ice along here that's melting quickly. You can see through. It's cracked up and melting quickly there. Now here's some clouds, but here's the ice edge along here, but it's ice free around this coastline. Here's Barrow, Alaska. Here's the Bering Strait. It's been ice free for a long time. This is the Chukchi Sea. This is a big cloud. And then here's the Russia Siberia coastline. Look at this. This is today. There is no ice there. You can see the sediment, the brown. This is from the river coming out. This is the seafloor underneath there. Here's a little bit of tiny ice here. This is a cloud. Here's just a little remnant of ice. You see the little pieces there. This is a cloud. And it's raining up here. This is rain. Here's the ice edge right here. Let's see, this is open water. Ice free. When it melted good. So here's the edge. You can see it. Here's the 80-degree north latitude line. Circle. and the North Pole is right there. Here's the edge coming down. Here's Anomaly. Right around here is where we've been seeing the methane coming up since January. There are numerous ice caps on this group of small islands, and they're melting. This is the Vovolov. This is still flowing. You can see it flowing into the ocean there. Right there. Now see, it's melted all around here. This is a little bit of ice around in between the islands. Here's Anomaly. These are clouds. There's no ice. That's ice free. Here's Franz Josef Land. Here's Svalbard. No ice there. Here's the ice edge. It's gone way in. And here's Greenland. And here's where that hole is opening up on this eastern side, kind of heading southeast. And we can also see smoke from the wildfires. See all this? This is smoke, this gray wispy. That's moving across the Arctic, and smoke over here too. A lot of smoke. While we're here, I want to show this volcano. Not many people know about this. This is what's causing all that sulfur dioxide. It's down here. I have to find Japan. It's right down here. Yesterday was a very productive day for the volcano. See, it's coming up from here. And this black area, they do that to flatten out the map. But look at this. Here was another weird thing. Look at all this missing data yesterday on NASA Worldview. It's just below that volcano. So I don't know what they didn't want us to see. But the sulfur dioxide is coming all the way across the Pacific there. So here's the volcano. Here's yesterday. Here it is today. It's kind of dissipating out. Here was the 10th, 11th, 12th. That was a good day to see it. And a big cloud. This could be water vapor coming up. Here's the 7th. So you can see the difference from day to day. Here's the 6th. It's been spewing since June the 19th. Here's July 5th, 4th, 3rd, 2nd. Here's July 1st. It looks like it's increasing. Here's the 28th of June. Not much. Here's the 27th. That's a big day. 26th. 25th. 24th. 23rd. 22nd. Clouds. Clouds on the 21st. Clouds on the 20th. and on the 19th, that's when it began, and you can't really see it. It doesn't show up really on satellite until the next day, but it was cloudy. Here we can see that plume is probably from it the 23rd, and then here we go, you can start seeing it. But it looks like it's picking up steam through these days. Look at that. Here's a blowout day on July 6th and July 8th, the 10th, and look at this on the 11th. It was awful. That was yesterday and today. So there you have it. There's the cause of our sulfur dioxide. So I'm going to go ahead and wrap this up, and remember that time is short, and if you haven't gotten your spiritual house in order, I recommend it now. No one knows when your last breath will be, but I recommend we all be ready anytime, any day now. Time is short. I love you guys. So God bless you. Go in peace, and I will talk to you soon. Goodbye.